Here we go. Exercise 4G, determining rules again. So very similar to what you did previously. Let's see what you guys can do so far. So here's a graph. So there's 4G, question 6E. Find the expression for which defines this cubic. So we know it's a cubic. Looking at the graph, we can already see x-intercepts at -2 and 3. And they gave us x plus 2 here. So what is likely in the second bracket here? Can I please have, let's go with Phoenix. What do you think? What can we match up with this graph? What can we say?
Well, it only has two intercepts, so like x minus 3 squared.
Very good. Now you said x minus 3, which is correct because that has an x-intercept at 3. So if you rearrange it, it becomes x minus 3. That's the null factor law, but reversed. Okay, so hence the factor should be an x minus 3. So that's correct. Then you said another key thing. You said squared. Why did Phoenix say squared? Can I please have Luke? What did he say squared for? Very good. So logically, you can also say that's a linear factor. So 1x times an x squared will then give you the cubic. Alternatively, there's also another thing from the graph that you can identify. What else can you also identify from the graph? Let's go with Sarush. Very good. Okay, so look at if there's a turning point for the x-intercept, which is my previous lessons, that should imply there's a repeated factor. If it's an inflection point, it should be a cubic factor. So yes, that's pretty much all you got to do there. What am I missing? Well, I don't know, but it actually is going to give me a y-intercept at 0, 18. So you test it by subbing 0 to see if it actually gives you 18, because if it doesn't, that means there must be a linear, a factor dilation, or a dilation of a factor that's involved. Okay, so test it. 2 times 9, it does give you 18, so all good. Answer's already set, but at least you can see my thinking. Is there a dilation factor? How do you test? Test the y-intercept. Because from the graph, we can see it's 0, 18. Test by substituting x equals 0. Does it equal to 18? If it does, then that's your equation. Cool. That was one example. Let's try this one. Tech-free, multiple choice question 1. You've got a set of values of d for which the following graph, and I'm going to pause the video to give you guys some time to have a try. So you can use CAS, but I purposely put tech-free so that you can't. Okay, so this is a CAS question, but I want you to do it tech-free. You got y equals x cubed minus 6x squared plus d. You don't know what d is. Has 3 distinct x-intercepts. So that's a hint. That's the biggest hint for you. So what is d? Is d greater than 0, meaning positive, negative? D is 0 or 32. D is between 0 and 32, or d is any number. I'll give you 90 seconds, because that's usually the suggested time to figure out the multiple choice question. But for you guys, I'm going to give you 2.5 minutes, because you're going to have to do it by hand. Slight change. Pause the video. Go 3, 2, 1. So this question. Yes, it feels unfamiliar because we don't know what d is, but what you can also do is you can say say, I don't know, g of x equals to x cubed minus 6x squared. Why? Because then you change it to y equals g of x plus d. Now we know that through transformations, d should govern whether it goes up or down, right? So the question is, what does g of x look like? And g of x, that we can sketch. This one we can visualize. X cubed minus 6x squared. Another way of thinking about it is if you take out a common factor of x squared, then you got x minus 6. That tells us, just from looking at that, which is linked to the previous question, this is a repeated factor at 0, and then it crosses through x equals 6 as your axis intercept. So there should be 2 intercepts. You got 0 and you got 6, and it's a positive cubic, so it must be something like that. That's what g of x would look like. Now the question is, what should d be? So d governs whether it's a vertical translation. So Do I move it up or down so that I get 3 distinct x-intercepts, meaning 3 separate x-intercepts? Right now I only got 2. So logically, the only way to do this, and if I pick up the graph, is you add. So moving it up, so that's 1 intercept. Then now if you want 2 intercepts like this, and then if you want 3, there we go. Okay, so it has to be slightly increased, but not too increased, because there has to be a limit somewhere, doesn't it? Because if you keep going up infinitely, it'll be 1, and at some point it'll be 2, right? So you need to figure out when does it equal to 2, because right now you got 2 intercepts. So before you had 2 as well by shifting up, so there must be a height of d. So this one can't be the answer. This one can't be the answer. And it could be between D and 32. That looks like more likely. I haven't actually calculated, but I'm going to guess it's D, because 0 and 32 doesn't make sense. If D was 0, it doesn't move up, and 32 is only one value. So I would assume it's between 0 and 32. But we can prove and guess that. So how do we work it out? If we actually want to work out if it's 0 and 32, how do we work it out? I gave you a pretty good explanation there, but now, if you had to problem solve, how do you work out for 0 and 32? What would you do? Because the answer is likely D. Viva. You take the derivative, very good, so you can find the turning point, find the derivative stationary points. But remember, this is a CAS question, so you would have been able to just move up and down and we've got the answer. But if we were to do it by hand, derivative would have been the way, delta y, delta x, let it equal to 0, and then solve for x, and likely you would have got x equals 0 in, whatever this value is, you need to find the y value. Once you know the y value, you know how much up and down you must go. Okay, so that's if we were to do it by hand. Cool. Hands up, you got D. Cool. Well, now you know. That's a typical question I've seen here and there. So when you see something like that, try to find something that you can sketch. All right, let's go to the next one. Next one, I already got the solutions there because it's simultaneous equations. Technically, if it was CAS, you just type it in and solve. So I already gave it to you. Do that in your own space. We're going to try the next question because this one's just basic substitution of all the values in. So just a quick guidance for you. You've got 1, 2, 3, 4 points. Sub each point into a general cubic equation, which is ax cubed plus bx squared plus cx plus d. You get a, b, c's, and d's, but in one of them you'll find out d is actually -2. And so then you just have to simultaneous equation these two. So it just takes a couple of steps. So that means algebraically from chapter 2, that was your holiday work, that's pretty much what you're practicing there again, which I'm not really going to go through that. I'm going to assume that your algebra is relatively strong so you can look at my notes and then figure it out. But have a go first before you check my answers. Okay? I'm interested in the next one, which is 4H. Okay, so that's 4G. 4G is just literally understanding your polynomials and solving the problems by determining the equation. So this one's given 4 points, figure out the equation. This one was a bit tricky where you had to think about transformations and a function that you're familiar with. This one was identifying intercepts, so -2 and then the repeated factor. Okay, that's 4G. All right, team. I'll leave this here for those who are watching this video. And pause the video here to look at my solutions. Otherwise, 4H is literal equations and simultaneous, so very similar to 4G. That's why we're doing them both together. The only difference is you get what we call parameters. These are called parameters. Whoops. There's A's, not the X. X's and Y's are called variables. These are called parameters. And we know that students generally struggle with parameters. So that's one of the exercises. If you struggle with it, it's a good one to have a look at. So let's do the first one. How do we solve? It says solve the following literal equations shown below. So I'm trying to solve for X, but I got that A's in between. So here we go. I see that they all have a common factor of X. So I'm going to take out X as a common factor. You get x squared minus 7ax plus 12a squared is equal to 0. This is pretty good. We move from a cubic to a quadratic. Now the next step, this is probably where some students will struggle, but how do I factorize this quadratic? Because we're obviously going to be using cross method. And it was designed for you to be able to do cross method. Anyone know what's in the brackets? Hands up if you know. Jacob? Beautiful. X minus 4a and x minus 3a. And again, how do you do it? Very similar to what you did in year 9. Find factors of 12, but now it's 12a squared. So you could have had, like 1a times 12a. You could have 3a times 4a. You could have 2a times 6a. It's the same thing, just with an a. Okay, so then doing the cross. The nice thing is the coefficient in front of x squared is 1. So really you only got 1 and 1. So when you do cross method, it's either 1 and 1 with 3 and 4, or 1 and 12, or 2 and 6, but you need 7. The only numbers that likely is going to give you 7 is 3 and 4. So that's where Jacob likely would have got my 3a and 4a to get that negative 7. Okay? That's for the people who don't know how to do this. And then here we go. We answer the question. So using null factor law, we can say x can equal to 0. We can say this one, x equals 4a, and this one, x could equal to 3a using null factor law. For those who don't know what null factor law means, it means that if you're multiplying them, one of them could equal to 0. So all of these, you have to solve for x minus 4a equals 0, and also solve for x equals 0. Okay, so if you solved it using linear equations, that's how I got x equals 4a and x equals 3a. So far, so good. So that is solving literal equations, because I've solved for x, but I just don't know what a is. But once I know what a is, I will know what x is. Okay? Have a go. Well, the next one, I'm going to pause the video. Let's have a look at b again. We go back. This one, when I see something like this, I mean, you could do completing the square and then difference of perfect squares. For me, just use quadratic formula. Because your goal is just to find what x equals to. So it's perfect and nice to say a is equal to 1, coefficient of x squared, b is equal to negative k, and then c equals to positive k. Quadratic formula says x, which is what we're trying to find, x will equal to negative b plus minus square root, b squared minus 4ac, all over 2a. So if I put it all together, it should be what? Negative and negative is positive, so positive k plus minus k squared minus 4 times 1 times k, which is 4k, all over 2. There you go. Is there anything I need to be careful of? I factorize k out. No. Seems okay, although there is a restriction on k. So if you just look at this bit here, k, this is just me being a bit pedantic here, but k has a restriction because what can't you square root again? Negative. But if you sketch this graph, k squared minus 4k is the same thing as saying k times k minus 4. So it's 0 and 4 for k, and it's a positive graph. So between 0 and 4, k will be negative. The answer will be negative, and so therefore you wouldn't have a value at all. So you'll need k to be greater than 4 or less than 0 for that to work. But I guess they're not asking for k values, but if I were to be specific, I'd say there will be x will equal this, providing that k is less than 0 or greater than 4. Okay? Less than or equal to. Anyways, those are just things to think about when you're doing the algebra component. Always think, is there a limitation? What should I be careful of? Those are worthwhile thinking about rather than just running through it. All right, example 2. If you were doing example 2, so 4H is a nice one to practice. I think a lot of parameters students struggle with. So I was saying before, find common factors. So x cubed, x to the power 4, x squared. They all have a common factor of x squared. Then you end up with a quadratic. Now they say only one solution. So this quartic can only have one intercept. But to have one x-intercept, you can already see you're already going to get x equals 0. So you need this quadratic component in blue to not have any solutions at all. So how do you ensure a quadratic has no solutions? Make sure that the discriminant, so the a value, whatever a is, needs to make it So that discriminant is negative. So then I go, okay, well, discriminant is b squared minus 4ac. A is clearly 1. B is A, and then C is, so I'm going to write here B, A, C. Sub it all in, and I get a squared minus 8. So if I sketch the discriminant graph, here's my discriminant. Here's my A values. And it's a squared minus 8. So it's a quadratic graph that's dropped down by 8. When we solve for the intercepts, it would be root of 8. So plus minus, that's why I've got the intercepts over here. And we want, when is the discriminant less than 0? This is when discriminant's less than 0. As we said, this is your y-axis. That represents discriminant now, because I'm sketching discriminant according to x, which is a. So this underneath this graph, when will the discriminant be less than 0? It's between negative 8 and root 8 and positive root 8. So therefore, in order for this entire quartic function to have only one solution, I need A to be between negative root 8 and root 8, or you can simplify it to negative 2 root 2 and positive 2 root 2. Okay, that's a very typical 4H exercise. So like I said, last year, if I gave this to my year 11s, that would be a big struggle for most students. Okay, so hopefully up to this point, you're feeling somewhat more doable. And for those who are really strong, you should find that as a nice question to do. All right, last question. Let's flip over. These ones I'm going to leave the solutions here because that's a basic substitution and then factorize and solve. So I'm going to leave it there for you to copy. But I want you to, for those who are sort of comfortable with their algebra, this one actually requires some thinking now. So textbook question 20. Have a go with it. Have a look at the next one. I'm going to pause the video. I'll give you, how long would this maybe? 5 to 6 minutes of a bit of thinking. 5 to 6 minutes. I could have given you more space. It's just that I didn't want to print too much, so I squeezed it all in one. So you might need some extra space inside. Have a go with this one only if you're pretty comfortable with what I've just been describing. So if you feel comfortable with parameters, you're comfortable with sketching inequalities and analyzing graph, it's worthwhile having a go at this. If you're not, don't do it. You look at these notes and you can go with those ones. That's probably where you're sitting at the moment. This one, you can watch my videos later. Okay, here we go. I'm going to give you, say, 6 minutes. I'm going to pause the video. All right, let's see if you guys got them right. If you attempted this question. First one is solve for y equals mx and y equals 1 on x plus 5 for x in terms of m. So really it just means equate them and then solve for x. So I equated them right here. Mx equals 1 on x plus 5. I times x to all of them to get rid of the denominator. So I get mx squared plus 1 plus 5x. Move everything to one side. I get a quadratic. From that quadratic, I just simply use quadratic formula to find x, very similar to the previous example I had with you before. And that gives me an equation for x in terms of m. What is this? So interpretation, if you're thinking about the problem, this tells me the x coordinate of the intersection of the two lines. Because you're trying to simultaneous them. So it means you're trying to find when these two intersect. So if there is a solution, that x represents the x coordinate of the intersection. Cool? So that links into the next question. Next question. Find the value of m. So what can I change for m so that it becomes a tangent to the graph of 1x plus 5? So it means it has to touch it. But if it touches it, it means that the x coordinate, there's only one answer. Right now you've got a plus minus, so you can potentially get two answers here, because that's a quadratic. So instead of a line crossing through this hyperbole, it's only going to touch. So the only way to have one solution is that the discriminant has to be 0. This quadratic solution that you're solving for, which you're solving for the intersection between two graphs, has to only have one solution. That's what the discrimination represents. So you're saying square root of 0, as long as that equals to 0, you only get one answer. So I said, all right, well that means 25 plus 4m, which is inside the square root, has to equal 0, and that means m has to be negative 25 on 4. If that's the case, this one I know is going to be 0. There's no point subbing it in. It'll be 5 plus minus 0 divided by 2 times m, so negative 25 on 4. Do a bit of fractions division, or on your CAS. You should get negative 2 on 5. That's the x coordinate of the intersection. But they said, give the coordinates of the intersection point means they want both x and y. So to find y, you can sub it back in here to find y, but I just thought, why sub it back in here when this one was y equals mx? M you know, and x you found out. So multiply those two together, that's what I did. So y equals mx, here's m, here's x, times them together, you get 5 on 2, so now I know point of intersection, which is only one of them, is that negative 2 over 5 and 5 on 2. So that was the real cool part where you had to think about, what does this mean? Because in chapter 3 quadratics, this meant x-intercept. But in this particular scenario, this represents the intersection point, the x-point of the intersection point. That's the interpretation. Okay? All right, and then the last one was then analysis of your discriminant. So if you want to make sure these two graphs don't intersect, well, it just means the discriminant is less than 0. I just took the discriminant, which we already knew is 25 plus 4m, sketched it. Here's your linear graph. Here's the m-intercept, which is the x-intercept, and then the y-intercept. So here's your graph. This is when discriminant is less than 0, that I highlight in blue. So as long as m is less than negative 25 on 4, I'm pretty good. And you can test that through Desmos as well. We'll chuck it all in just to see how it sort of plays around. But that's the analysis. Now I did that by hand. You could have done that much quicker on a CAS, which is what 4H is about. Cool? All right, team. So that's all. I tried to power through 4G, 4H so that we're a bit ahead to give a breathing time when I'm away. But that's pretty much what chapter 4 is. 4H to me is probably more useful, but you can only get there if your algebra is strong. So 4G and everything beforehand, you got to be pretty good. Your SAC is pretty much everything from the start of the year, plus your holiday work up until now. Yeah, so it could be any of those variations. Exam 1 style. It's like a TSSM stuff. So if you want to practice more, do some chapter review, look at the TSSM stuff. That's the kind of writing we'll be doing. Okay. All right, that won't be until week 9. Week 9, remember, no CAS, but you can bring notes. One bound reference. All right, I'm going to stop the video.